Have you ever wondered why all planets are circular? This question might seem straightforward, but it's a gateway to a grand cosmic conundrum. When we gaze up at the night sky, we see celestial bodies, planets, moons, stars, all appearing in a similar spherical form. This isn't a mere coincidence or a trick of the eye. There's a profound scientific reason behind it. The circular shape of planets is a testament to the fundamental laws of physics that govern our universe. It's an intricate dance of forces, matter and energy, choreographed by the invisible hands of gravity and inertia. These forces shape not only our Earth, but also distant planets, stars and galaxies. So why are planets circular? It's not just about aesthetics or happenstance. It's about the fundamental principles that weave the cosmic tapestry of our universe. So prepare yourselves as we embark on this cosmic journey. Let's dive into the science behind this fascinating phenomenon. Gravity, the invisible force that keeps us grounded, plays a key role in shaping planets. This omnipresent force, which pulls everything towards the center of a mass, is a significant player in the cosmic drama that forms planets. To understand gravity's role, let's imagine a planet in the making. Initially, it's a massive cloud of dust and gas floating in space. As the particles in this cloud begin to collide and stick together, a process known as accretion, they form a larger and larger mass. As the mass grows, so does its gravitational pull. Now here's where things get interesting. Gravity doesn't pull more strongly in one direction than another. It pulls equally from all sides towards the center of the mass. So as the forming planet continues to grow, gravity pulls in the material from all directions. This inward pull of gravity leads to what scientists call hydrostatic equilibrium, a state of balance between the force of gravity pulling inwards and the pressure of the material pushing outwards. It's this equilibrium that shapes a planet into a sphere. Why a sphere, you may ask? Well, a sphere is the shape that allows for the least amount of gravitational potential energy. In other words, it's the most efficient shape that a massive object can take to contain its material. And this isn't just theory. We see evidence of this in our own solar system. Most celestial bodies, including Earth, Mars, and even our own moon, are spherical. They aren't perfect spheres, due to factors like rotation and uneven distribution of mass, but they're close. So, in essence, gravity molds planets into spheres. It's the master sculptor of the universe, shaping celestial bodies into the most efficient form possible. This spherical shape isn't just aesthetically pleasing, but it's a physical necessity, a testament to the universal law of gravity. But how does the process of planet formation contribute to their shape? To answer this question, let's dive into the cosmic kitchen where planets are cooked up. Our recipe begins with a massive cloud of dust and gas known as a nebula. This nebula is the raw material for stars and planets, a celestial soup that's just waiting to be stirred. Now picture the nebula as a bustling city, with particles representing the citizens. Each particle, or citizen, has its own gravitational pull, a kind of charm, if you will, that attracts others towards it. Now, as these particles move about, they start to bump into each other, stick together and form clumps. These clumps grow larger and larger, attracting more and more particles like a popular socialite at a grand party. As this process continues, the clumps start to form what we call planetesimals, the precursors to planets. These planetesimals continue to grow, their gravitational pull becoming stronger and stronger, attracting more matter and growing into protoplanets. Now here's where things get interesting. As these protoplanets grow, their gravity becomes so powerful that it pulls everything towards the center, equally from all sides. Imagine a group of people all trying to get to the center of a room at the same time. They would naturally form a circle around the center. The same principle applies here. The pull of gravity from all directions molds the protoplanet into a spherical shape. This process continues, with the protoplanet's gravity pulling in more and more matter, and the heat from these collisions causing the planet to become molten. This molten state allows the planet to further adjust its shape, smoothing out any irregularities and perfecting its spherical form. So you see, the process of planet formation is a cosmic dance choreographed by gravity. From a nebula's dust and gas to a fully formed planet, Gravity is the maestro conducting this celestial symphony, pulling and shaping matter into the familiar spherical shapes we see today. Therefore, the process of planet formation inherently leads to a spherical shape. While most planets are spherical, there are some exceptions. This might come as a surprise, but not all celestial bodies are perfect spheres. Certain factors like rotation speed and the presence of moons can influence a planet's shape. Take Saturn, for instance. It's not a perfect sphere. Why, you ask? Well, it's primarily because of its rapid rotation. Saturn spins so quickly that it bulges at its equator and flattens at its poles, giving it an oblate shape. This oblateness is not unique to Saturn. It's a common feature among rapidly rotating planets and stars. Now let's talk about moons. Moons can also affect a planet's shape. A prime example of this is the Earth and our moon. The gravitational pull between the Earth and the moon causes a slight bulge in the Earth's crust, creating what we call tidal bulges. These bulges make the Earth appear slightly egg-shaped rather than a perfect sphere. Another exception to the rule is Haumea, a dwarf planet located in the Kuiper belt beyond Neptune. Haumea is unique in that it has an elongated rugby ball-like shape. This unusual shape is due to its incredibly fast rotation and the presence of a large amount of ice in its composition. But wait, there's more. Asteroids, for example, are notorious for their irregular shapes. Many asteroids are simply too small to have enough gravity to pull themselves into a sphere. As a result, they often look more like potatoes than perfect spheres. However, despite these exceptions, the rule of spheres in space is generally true. For a celestial body to be considered a planet, one of the criteria it must meet is that it has cleared its orbit and has enough gravity to pull itself into a spherical shape. So even though there are celestial bodies that break the mold, the majority of planets in our universe are spherical, or at least very close to it. The exceptions to the rule merely serve to prove it. Even with these exceptions, the rule of spheres in space holds true for most celestial bodies. So why does it matter that planets are spherical? Well, the spherical shape of planets has far-reaching implications, from the way they move in space to the potential for life as we know it. It's a fascinating subject that truly underscores the intricacy and beauty of our universe. Let's start with orbits. The spherical shape of planets allows them to have stable orbits around their stars. This is because a sphere is the shape that minimizes gravitational potential energy, leading to a stable system. In simpler terms, a sphere is the most efficient shape for a planet to assume if it wants to keep a steady, predictable path around its star. This is particularly important for life as we know it. You see, for life to exist, conditions on a planet need to be relatively stable. The steady orbital path of spherical planets allows for consistent cycles of seasons, day and night, and other environmental factors that are crucial for life to thrive. Now let's talk about gravity. A planet's shape directly affects its gravitational pull. A sphere, being symmetrical in all directions, has a consistent gravitational pull. This uniformity helps hold an atmosphere around the planet, another vital ingredient for life. A non-spherical planet, on the other hand, would have an irregular gravitational pull. This could lead to a thinner atmosphere in some areas and a thicker one in others, which could result in extreme weather conditions and make the planet inhospitable. So you see, the spherical shape of planets is much more than just a cosmic aesthetic. It's a fundamental aspect of how planets function and interact with the universe around them. This brings us to the grand revelation. The shape of planets is not just a matter of physics and mathematics, it's a matter of life. The perfect symmetry of a sphere might just be the reason we're here, contemplating the mysteries of the universe. So the shape of planets is crucial not just for their formation, but also for their potential to harbour life. Let's recap what we've learned today. We've journeyed through the cosmos, understanding why planets, including our own, are spherical. We've learned that the primary architect of this shape is gravity, a force that pulls matter equally in all directions, moulding celestial bodies into spheres. We delved into the fascinating process of planet formation, where dust and gas coalesce over millions of years, gradually forming a round planet under the unyielding influence of gravity. Our expedition didn't stop there. We explored the intriguing exceptions to the rule. Celestial bodies that, due to their rapid rotation or irregular composition, deviate from the perfect spherical shape. Finally, we pondered over the implications of spherical planets, from the distribution of their climates to the way they interact with light and other celestial bodies. Next time you look up at the night sky, remember the incredible forces and processes that have shaped the planets into the spheres we see today.